Hello students, how are you all? Welcome to our lecture series on trigonometric function. We have already uploaded plenty of the videos on our channel depending on the trigonometric function topic. So already I have uploaded first solution for trigonometric equation which included general solution, particular solution. After that I explained here to you all sine rule and along with some of the examples from board exam, and plus there we have polar coordinate and Cartesian coordinate. So I explained all these topics in my previous lecture. So if you are interested to see these videos, check it into my playlist. You will get the all these videos there. So in our today's video, we are going to learn one of the very much important topic from trigonometric function, which is a cosine rule and a projection rule. So already we have learned sine rule and some of the examples based on it. So in now today's video, we are going to learn cosine rule and projection rule. So without further ado, let's get started our today's lecture. So we'll see how our lecture it is there. Okay, now here in our complete lecture series for solution of a trigonometric equation. Okay, so already I explained to you all sine rule. Now it is our today's lecture part. We have trigonometric for the cosine rule and projection rule. Okay, first of all, we are going to understand first cosine rule and then we'll move for the projection rule. Okay, now let's start next part. Okay, so here we have a cosine rule. Okay, so I consider here a triangle ABC. Okay, under this triangle we have to prove a cosine rule here. Okay, so cosine rule, it says that a square which is equal to b square plus c square minus twice of bc cos a. So there are we have three formats of a cosine rule. Okay, this is a very much important topic for your board exam, as you going to if we see our previous year question papers, you can easily see these questions, type of the questions in your board exam. Okay, so proof of a sine cosine rule, maybe it is coming for 3 or 4 marks, and even if it is proof not there, then you will get the question based on cosine rule. Okay, so before I start my cosine rule, so I wanted to explain to you all some of the basic concept which we needed here in our cosine rule. Okay, so let's get started. So here, let me explain first of all the side for our cosine rule. So we'll use this results in our theorem, and then we'll go for the complete proof of our cosine rule, which is very much important for your board exam. So be careful about this proof. Okay, so here, so we can plot here one triangle. Okay, so if I consider this axis, and this one is the triangle here. Okay, now see that we have to understand first of all which side, where it is which side. Okay, so the small sides and their angles, we have to understand it first. Once we come to understand their sides and angles, then further part is easier. Okay, so here it is 90 degree. Okay, so here we can see we have triangle a b c. Okay, so we need to understand first of all three sides and three angles of a triangle. So once you come to understand sides and angles of a triangle, then it is easier to prove cosine rule. Okay, so proof it is similar like sine rule, what we done in a sine rule. There are little bit calculations, same we have to apply over here in cosine rule. Okay, so you will get the easy proof. Now here we can see we have triangle ABC. So here we always consider it is the angle A. Okay, this one is the angle A, this one is the angle B, and this one is the angle C. Okay, so each vertices there exists a particular angle. Okay, so we always consider in trigonometry that here we have the close of our first vertices will get the first angle, second vertices second angle, and third vertices third angle. Now we have to understand the sides of an angle of a triangle. Okay, so side small b always goes to the front side of the b. Okay, small b side always goes to the front side of the angle b. Small c, it goes to the front side of angle c, and that one is a capital C and that one is a small c. Okay, you need to be careful about the small and capital letters, because small letters always denoted the distance from the sides, and capital letter it denotes the angle of a triangle. Okay, so now small a we can take it here. Okay, we have the sides and angle of our triangle. Okay, so I hope you all have understood how can we define sides and how can we define their angles. Okay, now let's get start a proof of our today's theorem. Okay, so our theorem, it is from the cosine rule. So generally we have three different statements for the cosine rule. Okay, in your board exam you don't have to prove all of the statement in your exam. So what you need to do, you just need to grab one of the statement from there and go for the complete proof of this statement. Okay, so just we have to prove one statement, because similarly second and third statement are same. Okay, so we'll consider here first statement, a square is equal to b square plus c square minus choice of bc cos a. I will go for the proof of this theorem, and then after we can conclude here that second and third option can be similarly proved by first statement. Okay, so let's start our proof of theorem. Now here's now here we have one figure that it shows vertices A at the origin, B at here on x-axis, C it is the point between x and y-axis. Okay, so I drew one triangle here. So with respect to that triangle, we have to define cosine rule. Okay, so cosine rules are having their other format. So we'll see after completion of this proof. Okay, now see that. So here we have angle A, here angle B, and here angle C. Okay, now using each and every angle, we have to prove their sides and their ratios for sides. Okay, now here we can see we have triangle ABC. Okay, so in our triangle ABC, in triangle ABC. Okay, here we can see the triangle ABC. Now we can see that if we want the value for A, so here we can see we have the coordinate for vertices A, which is at the origin. So we can consider it as the 0, 0 coordinate for the origin. So if you go for coordinate B, so coordinate for B, we can say that the x-axis which is present here, that means you will get the only coordinate for x-axis and y-axis 0 there. Okay, so you will get the B of C 0, and third coordinate, it is the combination for x, point of x and point of y. Okay, that means point of x means the distance from x and the distance from y here. Okay, so this is the coordinate for C of x comma y. Okay, this is the distance of coordinate for C of x comma y. So how we can find that x and y? Here we can see. So if you want the coordinate with respect to angle A, so we use sine A and cos A. Okay, sine A can be written as, how can we write sine A? Let me explain how these coordinates are coming. Okay, sine A, we can see that opposite side A, and you may take this one as the hypotenuse. Okay, A upon B. So for finding the value for A, we can write it as the B sine A, which is equal to small a. Okay, so here we can see the value for small a. Okay, that's A goes up, that means the measurement from here to here we are having approximate measurement we are having as a side A. Okay, side A which is equal to B sine A, that means the upper coordinate it goes to for the y-axis. So we can say that for y-axis we use a B sine A, and similarly if we apply for the x-axis, that means A to B here. Now applies cosine, that means cosine for the angle A. So cos A, okay, so we want for the cos A. Similarly do it for the cos A, you will get the B cos A. Okay, so what we will get the A by B, we will get the cos A as A divided by B. Okay, because we take for cosine adjacent upon hypotenuse. Okay, so as we needed here the value for x and y, so we have to consider the value as we needed here. Okay, so go through this way, then you will get the required answer. Now cos A can be written as B cos A, which is equal to small a. Okay, so you can see that B cos A we got it here, and B sin A we got it here. Okay, so we got the coordinate for x and y. I hope you all have understood this coordinate. So we have to consider this coordinate for finding the proof of our cosine rule. Okay, now we can see that. So using our diagram, we can see that the point B and C we have here. So can we use the distance formula between B and C? So we'll get the value for A. Okay, because our proof in the form of A square. Okay, proof it is in the form of A square. So we have to find out the value for A. Okay, and for finding the value of a, so we can use it here as a distance formula. Okay, so what is the distance formula here for a? So we can write by distance formula. By distance formula, okay, you can see here the distance formula between C and B can give us the value for a. Okay, what is the length of that side, which is a small a? Okay, so we want the value for small a. Okay, because we have to prove the cosine rule as a square. Okay, so for proof of the a square, we have to find out first of all a, and then go for the a square. Okay, so how can we write the distance formula between 2 points? Okay, so for example, if I consider x1 y1 at first point and x2 y2 is our second point. Okay, and we want the distance between these 2 points. Okay, so how can we take that distance? We take this distance using distance formula. Okay, distance formula, it says that x2 minus x1 second coordinate minus first coordinate bracket square plus y2 minus y1 bracket square. Okay, so this is actual distance formula for our proof, next proof. Okay, so we will use that distance formula here between the point B and C. Okay, so what will get the distance between point B and C, which is equal to, we have A. Okay, and A can be written as the under square root the second coordinate minus first coordinate, and similarly second coordinate minus first coordinate. So we write this one as, okay, so we get this distance between B and C, which is the under square root, okay, first coordinate C minus, that means second coordinate minus first coordinate, so C minus B cos A bracket square. Okay, C minus B cos A bracket square, again 0 plus, between there we have positive sign, be careful about the sign, and 0 minus B sin A, 0 minus B sin A bracket square. Now we can see that I have applied here the distance formula between point B and point C. Okay, now using the distance formula, go for the further calculations, so we'll get the their perfect answer. Okay, so we can, what we do first, we have to find out the square of first bracket, and the second will remain as it is. So what is the square of first bracket? So a minus b square, so we have to use the result a minus b bracket square, so a square minus twice of ab plus b square. Okay, now so we can write this one as c square minus twice of c into b cos a. Okay, a square minus 2 times ab plus b square, that means b square uh, and a cos square a. Okay, so we have the expansion for this bracket square as a square minus twice of ab plus b square plus, now negative of a b sin a bracket square, so negative square it comes as a positive, so we write it as the plus b square sin square a. Okay, so we got the distance between these 2 points as a which is equal to this quantity. Okay, so c minus b cos a bracket square plus 0 minus b sin a bracket square, their expansion it is here. Now see that b square into cos square a plus b square into sin square a. So we know one more identity, which is a cos square theta plus sin square theta. What is the value for cos square theta plus sin square theta? Which is 1. So use this result here. So cos square theta plus sin square theta, it gives us the value 1. So we write this step as, so c square minus choice of cb cos a plus this quantity gives us only the value b square. Okay, this quantity gives us the value only b square, because b square cos square a plus b square sin square a, take b square common from these two terms, so you will land only with a b square under bracket cos square a plus sin square a, and the cos square a plus sin square a are defined as a 1, so put the value, it is 1 here. So we left here with the term c square minus twice of cb cos a plus b square. Okay, How this b square? Because I applied here trigonometric result. So this is the value for a. So we want the value for a square. Okay, so we want the value for a square. So how can we write a square? We can write a square as a take the square from both of the sides. So a, which is equal to this term, that means take the square from both sides. First a square, which is equal to remaining square root square. So square root and their square can get cancelled. So we get the last term as a square, which is equal to c square plus b square, c square plus b square minus choice of bc cos a. Cos a. Okay, choice of bc or choice of cb cos a, both are having same meaning. Okay, so this is the required proof. This is the required proof for our first statement. Okay, so it gives us, our statement gives us here a square is equal to c square plus b square minus choice of bc cos a. Okay, this is the required proof for our theorem. As we have second and third part here, so you can go for the part second and third similarly like part first. Okay, I hope you all have understood my part first. Similarly go for part second and part third. And if you apply same condition and concept on our part second and third, similarly you can get the proof of our required theorem. Okay, similarly try for part second and third. Do it for part second and third because it is a similar proof, it is there. Okay, and now in our next part what we do, we'll go for the different form of a cosine rules. Okay, different form of a cosine rule. So how we can define different form of a cosine rules? So here in our slide we can see we have a square is equal to b square plus c square minus choice of bc cos a. Again we have second condition, b square is equal to c square plus a square minus choice of ca cos b. Okay, so there is some trick that you can remember this result. Okay, so I'll tell you that one, but just we have third result here, c square is equal to a square plus b square minus choice of ab cos c. Okay, these are, we have three different identities from cosine rule. Okay, I hope you all have understood this identity. Now go for some of the adjustment of terms in our identities. So you will get the value for thetas. Okay, for finding the theta, so we will adjust these terms here. Okay, now so how can we adjust our first identity? Here we can see a square, which is equal to b square plus c square minus choice of bc cos a. Okay, so we want the theta here. Okay, what we want the value for theta. So we want the value, means we want the value for cos a. Okay, okay, for finding the cos a, take the remaining term to the other side. So we'll get the a square minus b square minus c square. Okay, a square keep it is positive, b square as negative b square, c square as a negative c square. Okay, and which is equal to, so negative of 2b cos a. Okay, so here we have the next part of this calculations. Okay, so here we can see I kept a square as it is, negative b square negative c square is equal to negative twice of bc cos a. Okay, so for finding theta, for finding cos theta, so what we do, take these terms to other side. So we'll get the a square minus b square minus c square upon twice of b, which is equal to negative twice of b, which is equal to cos of a. Okay, so this is the value for cos a. So if you have given the sides a, small b and small c, if you are given three sides, then that time how can you deal such a question? So that time you have to use theta, like a b c, like this theta you have to apply. Okay, so that means for finding the angle a, so you have to substitute the value for a b c. Okay, these are the sides. So take that negative up here and multiply inside the this term. So we'll get the b square plus c square minus a square upon twice of b, which is equal to cos a. So this is our required proof for first cosine rule. Okay, which is the cosine rule means the results which comes under cos a. Okay, sine rule means the result which is helpful for sine. Okay, So this is the cosine rule. I hope you all have understood. This is the first form which I got it from the first identity. Okay, so which I got the using first identity. I got this proof. Okay, and now similarly using second identity, go for it. Okay, the complete proof you have to follow by yourself. Okay, as I have explained part first, similarly part second and third you have to try. Okay, go for part second and third, and now we have to find out the another form of a second rule and another form of a third rule. Okay, I hope you all have understood this one. Let's move for the another part. Okay, so we have to find out the second and third. How can we find the another form of a cosine rule for second and third, which I have given here as a remark, that cos A, cos B and cos C, these are the three different forms for our cosine rules. Now, so find out the value for cos B. How can we get that value here? So take that 2 times CA, 2 times CA cos B, 2 times CA cos B other side, and we'll get the C square plus A square. Keep as it is. Take that B square to the another side. We'll get the negative B square. Okay. So what I have done, that negative quantity I taken here and positive B square I taken here. Okay. The replacement of the values are there. So choice of CA, take it to the other side. So cos B will get the C square plus A square minus B square, okay, upon 2 times CA. So this is the value for cos B, okay, cos B which is equal to C square plus A square. That means the capital angle which is equal to remaining two sides C plus A minus the side front of the capital angle which is equal to 2 times remaining two sides. Okay, there is some tricks that we can remember these results. These are very easy results. Okay, I hope you all have understood these ones. Okay, now by using third result, how can we get the different another form? Similarly, apply the next concept here. So we'll get the cos of C which is equal to A square, keep as it is, plus B square minus, take that C square here, upon twice of AB it is there. Okay, so this is the value for cos C I found by using third condition. Okay, so using condition first, condition second and condition third, we have to find out the standard form of cosine rules. Okay, so I hope you all have understood this standard form. Okay, all these are given here in the remark, so you can see the first remark here as a first form of a cosine rule, second form here and third form here. So when we use these forms, when we have given the sides and whenever we want the theta, that time you have to use these forms, okay, in your board exam. And now in another condition, so if you have the theta given and some sides are given, that time you have to adjust as per your flexibility. Okay, you have to adjust that result as per your flexibility to get the required answer. Okay, so this is only the cosine rule for our today's lecture. I hope you all have understood this lecture, understood this cosine rule. Okay, so we'll go for some of the example based on cosine rule. Okay, now here we can see in our next part, we have in a triangle ABC, angle capital A is a 60 degree. Okay, angle A it is given. So we have to apply here some standard result for finding the value of a sides. Okay, so same example it coming for your board exam for 4 marks. Okay, very easy calculations are there. So we just have to apply one of the basic results like a sine cosine rule, then easily you will get the answers. Okay, these examples are coming for your board exam for 4 marks. Okay, 4 or 3 marks definitely they are coming. So if cosine rule are not there in your board exam, that means surely some of the example based on cosine rule there. Okay, so you have to be careful about this. Okay, now in our triangle ABC, we have triangle ABC. Let's draw the triangle here. Triangle A, B, C. Okay, we have triangle ABC, which angle A given 60 degree. Angle A is a 60 degree. Side B it is there. So small a here, small b it is coming here, and small c it is coming. Always remember the front of angle are these sides. Okay, so capital A is having a side small a, the front of this angle. Okay, so we have given B is a 3 and C given 8. Okay, okay, we have the B3 C8 and we how to find out the value for A. Okay, we have to find out the value for A, and also what we needed here, we want the value for a, and we want the circumradius of a triangle. So what is mean by circumradius? Okay, already we have learned this concept in a sine rule. Okay, so if you don't know the sine rule, check it in my playlist, you will get that sine rule and circumradius. Okay, circumradius means under circle, whenever we draw the triangles, the radius which is passes from that triangle, so we call it as a circumradius. Okay, so we consider it as the a upon sine a, b upon sine b, c upon sine c, which is equal to 2 times r, and r is there as a circumradius. Okay, so that result we also have to apply here. Okay, okay, now what we do here, first of all, we want the value for small a. Okay, we want the value for small a. So what we have the cosine rule here for finding the value of the sides. Okay, so we know that cosine rule can says that a square is equal to b square plus c square minus twice of bc cos. Okay, okay, so this is the our standard cosine rule. So if you don't know, if you wanted to see this result, you may check it here. Okay, so this one we are going to use b square plus c square minus twice of bc cos a. That result we are going to apply in our example. Okay, so a square is equal to b square plus c square minus twice of bc cos a. Okay, now what we have here, substitute all the values. A angle a, it is given 60 degree, so we want the value for a square, keep as it is. The value for b square, that means 3 square, plus c square means 8 bracket square minus 2 times bc, 2 times b it is here 3 and c it is here 8. Okay, and into cos a. What is the value for cos a? Cos 60 degree. Okay, so we want these values here. Okay, now see that 3 square, put all these value, 3 square which is a 9. Okay, and 8 square it is a 64. 8 is a 64 minus 8 3 is a 24 2 is a 48, and a cos 60. What is the value for cos 60? Which is a cos pi by 3, which is a 1 by 2. Okay, which is standard value, which is 1 by 2. Okay, so a square which is equal to this term. So go for the further calculations. So after calculation, you will get the a square as a 49. Okay, find out this addition subtraction, you will get the a square is a 49. Okay, and then we will get the value for a which is equal to plus minus 7. Okay, 7 square is a 49, plus 7 square 49 minus 7 square 49. But as we have small a is the side for our triangle. Okay, so if small a is the side for our triangle, that means we will take always a as a positive, because distance never negative. Okay, so we got the value for a which is equal to plus 7. Okay, I got the value for a which is equal to plus 7. And now we want the value for a circumradius. Okay, we want the value for circumradius. So how can we define circumradius? We know that a upon sine a which is equal to b upon sine b which is equal to c upon sine c. What we have this, which is equal to 2 times r. Okay, and r it is here as a circumradius. Okay, take one of the part from here. Okay, this is the part we will consider here. Okay, so we'll get the 2 times r which is equal to a upon sine a. Okay, 2 times r which is equal to a upon sine a, it is there. And now what we do, put the values here from a which is equal to 7. Okay, we have the value for a is a 7, and sine a, that means sine of we have here sine of 60. Okay, we have sine 60, 2 times r. Okay, 2 times r which is equal to 7 divided by sine 60. Okay, and we know that sine 60 which is having value root 3 by 2. Now substitute it here. So 7 divided by root 3 by 2. Okay, now what we do, take that 2 here, so we'll get the 2 as a denominator, so we'll get the value as a 7 divided by root 3 by 2 multiplied by 2. Okay, that 2 get cancelled with this one, so we'll get the 7 by root 3 as the value for r. Okay, which is equal to value for r. So this is the required value for r. Okay, so we want the circumradius as the value for r. So we can solve that value further also. So 7 by root 3 can be solved as 7 divided by root 3. Okay, multiply root 3 here, divide root 3 here. Okay, so we'll get the 7 times root 3 divided by 3. Okay, so this is our required circumradius for our triangle. Okay, I hope you all have understood the solution for this example. Similar examples are coming for your board exam for 4 marks. Okay, 4 or 3 marks. If cosine rules are not there in your board exam, so surely examples depend on the cosine rule. It will come in your board exam. Okay, so this is our required answer for R, which is the 7 root through 7 root 3 by 3. Okay, this is our last answer. So let's go for the next part, which is the projection rule. Okay, we'll go for some of the recap only from the projection rule, as we know that the only examples are coming on projection rule, not that proof are very important for your exam. Okay, so here we can see we have A, which is equal to B cos C, C cos B, B which is equal to C cos A plus A cos C, and C which is equal to A cos B plus B cos A. Okay, so we have these 3 separate proof condition for projection rule. Okay, similarly like sine cosine rule, we can prove the result for projection rule also, but I don't think so the proof is very not that important for your exam, but only the questions based on the projection rule it is coming for your exam. Okay, so to remember the different form of our projection rule, what we do, we just go through the understanding of different form of our projection rule. Okay, and that means small a can be written as, okay, now we can see that small a can be written as b cos c plus c cos b. Okay, now we can see here b times cos c, small a can be written as this side b times cos of angle c. Okay, plus after that small c cos b. Okay, small c cos b. So you have to remember one side, okay, one side a which is equal to the remaining 2 vertices and 2 angle can be addressed together. Okay, so a which is equal to b cos c plus c cos b. So this is the way. Similarly, we can go for the b which is equal to remaining 2 sides and 2 angles. Okay, so c cos a plus a cos c, and third one c which is equal to a cos b plus b cos a. Okay, and this is the way to remember the results. I don't think so the proof it is very much important, but you have to go through this proof. So as we have limitation of a time, so if you have difficulty there in a projection rule, comment me in a comment section. I will come up with some other videos. Okay, I hope you all have understood my today's lecture. So thank you everyone, thank you for my today's lecture.